Recording. Yes, so hello everyone. This is lecture 3 on discrete mathematics. And in the previous lecture, we were discussing translations. Okay, and I have told you translations regarding P implies Q. Okay, implies is like from left to right. Okay, if P then Q again left to right. So I have told you we have to manage the direction. Okay, we should know the direction. Q follows from P. So direction is from right to left and so on. I have told you many things. Okay. So we will discuss few questions. Okay. This is GATE 2001 question. So they are directly asking the converse. I stay only if
सर
you.
सर
Yes.
सॉरी सर बट
Mm-hmm.
सर पीछे वाले में ना मुझे थोड़ा समझ में नहीं आया सर वो मतलब बाद वाला जो अभी लास्ट वाला जो एक दो हाँ ये सब मतलब पीछे का ना दो तीन मुझे समझ में नहीं आया डायरेक्शन का इसमें कैसे डिसाइड हो रहा है वो मुझे मैं याद नहीं कर पा रहा हूँ मतलब
Okay.
समझा
Okay.
ही नहीं तो याद किया
नहीं ये इसमें कोई रूल रेगुलेशन नहीं है. वी हैव टू
यस
बाय हार्ट ऑल दिस थिंग्स. ओके. सो जैसे अब जैसे देखो दो तीन बातें हैं जो आपको माइंड में रखना है. इंप्लाइज तो सीधा याद हो रहा होगा आपको है ना. फ्रॉम लेफ्ट टू राइट डायरेक्टली है.
यस
ओके. इफ क्यू ये भी सीधा याद हो रहा होगा लेफ्ट टू राइट नो प्रॉब्लम. क्यू इफ पी ये इस तरह से याद रखना है. अब इसको कैसे याद करने का तरीका है आई आई विल टेल यू. देखो इफ के बाद पी है ना. सेम इज द केस
जी
हियर. इफ पी देन क्यू. So after if we have P, so direction is like this from P to Q. So same is the scenario here. If then P, na, so from P to Q direction will be like this.
यस
Okay, so you can make many rules and regulations. Q follows from P. Q follows from P, so you have to write like this. So for see, Q is following from the P. So if P should be true, then Q
फर्स्ट
should
इज
be.
की यस
So
यस
it left. Next P only if Q. So now see this. This is an
यस
exception. After it we
यस
are having Q. But it should be Q implies P, but still it is P implies Q. This is an exception. Only if. Okay, P only if you have to by heart this. And then Q when P. So that means what? Q is true when P is true. So that means what? If P then Q. So from right to left. Okay, next whenever again. When is from right to left. So whenever is again from right to left. Okay, then unless. Unless is just like or. Unless is just like or. So in English we are using unless, but in case of logic we will use or. So Q unless not P, that is nothing but Q or not P. So Q or not P means what? Q or not P like this. So this is nothing but P bar plus Q. So that is P implies Q. From Boolean algebra, I have told you all these things. Okay. P implies Q just like P bar plus Q. So from Boolean algebra, we can draw like this. So Q unless not P or not P unless Q. One and the same thing, they will represent P implies Q. Okay, so direction will, so forget about direction here because we will get confused here. So whatever is having not, that to which is having, we do not have not, from that we will go. Okay, so here we are having not, so from not
यस
like this. Here we are having not from here to here like this. Okay,
ओके
yes, so this is all about unless. Next is Q is necessary for P. See, necessary, if you want me to show you something, then I can show you like this. Okay. Q is necessary for P, so direction is like this, na? Q is necessary for P, direction is from right to left. Okay, why direction is from right to left? It is P implies Q. I will say like this. See, I have told you necessary condition and sufficient condition. So necessary condition means if necessary condition is true, I cannot say about hypothesis. If necessary condition is false, then hypothesis is false. This is 100% true thing, na? If necessary condition is false, then hypothesis should be false. So now I am saying direction is like this. So I am saying Q is necessary for P. So if I write P implies Q, so I will immediately say Q is necessary for P. Why Q is necessary for P? Because if Q is false, then P must be false. If, for
यस
example, if then P can never be true. You can check it out from the truth table. P implies Q truth table. False, 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 true, true, false, true, true. So when P is true, Q is false, then it is false. Otherwise, it is true. So directly, what I am saying is, if Q is false, then P can never be true. Directly, I want to say if P is false, then if Q is false, then P must be false. I am saying like this. So that's why I am saying Q is necessary for P. So that's why direction is from P to Q. Okay. So whenever we write P implies Q, so Q is necessary condition for P. Why Q is necessary condition for P? Because if Q is false, then P must be false. But if Q is true, I cannot say anything about P. For example, see this. If Q is true here, Q is true here. So P can be false or true. It hardly matters to me. Still P implies Q is true. This is very deep point. If you try to follow, then you will get it. Okay. So when P is false, when Q is false, then P must be false. But when Q is not say about P, it can be either true or false. So obviously Q is necessary condition for P. In P implies Q. Okay, I have told you now when necessary condition is true, hypothesis may or may not be true. But when necessary condition is false, hypothesis must be false. Okay, now see this. P is sufficient for Q. If I am saying like this, so direction was like this. So P is, so I am saying in P implies Q, P is sufficient for Q. Why P is sufficient for Q? See the truth table. See the truth table. P Q, P implies Q. False, 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 true, true, false, true, true. Okay, so now P is sufficient for Q. So that means if P is true, sufficient means what? See this. Sufficient means what? If sufficient is true, hypothesis must be true. But if sufficient is false, hypothesis may or may not be true. It may or may not be true. It matters to me. So just a second, just a second. So if P is true, then Q must be true. Okay, are you getting it? See this. True, true, false, and true. So see this. If P is true, then Q cannot be false. Now, if P is true, then Q must be true. Okay? But if P is false, Q can be the true or false. It hardly matters to me. P implies Q will be always true. So hence we can say P is sufficient for Q. Now say please. If anybody is having any doubt, please say.
No, sir.
Okay, someone else was saying something. Okay, so I hope your doubt is clear. So P is sufficient for Q means what? If P is true, then Q must be true. Okay, so hence P is sufficient for Q. And when P is false, I cannot say Q can be the true or false. See this. When P is false, then Q can be the true or false. It hardly matters to me. So that's why I'm saying P is sufficient for Q. And Q is necessary for P. So you have to remember this thing. In case of P implies Q, P is sufficient for Q and Q is necessary for P. Okay, Q is necessary for P. Necessary for P. And P is sufficient for Q. Okay, this is the rule. Okay, so I hope everything is fit and fine. Now I am starting the gate 2001 question. What it is saying? If I stay only if you go, and they want converse of this statement. So let me say like this: I stay is P, you go is Q. So I stay only if you go. So direction will be what? P implies Q. Okay, direction will be like this. Na? So P implies Q. Now try to find converse is what? See, P implies Q is direct. Converse is Q implies P. This is direct. This is converse. Inverse is not P implies not Q. Not P implies not Q is inverse, and not Q implies not P. That is contrapositive. I think you already remember all these things. I have told you P implies Q is direct. Q implies P is converse. Not P implies not Q is inverse. Not Q implies not P is contrapositive. So they want converse. Converse means like this. Q implies P type they want. Q implies P they want. So what is this? I stay is P, you go is Q. I have assumed this thing. Okay, I stay is P, you go is Q. So if direction was like this. Okay, so Q implies P. So we want this only. A is the option. And let me say the other thing. I say is P, you go is Q. If P then Q, so direction is like this. Okay, so next is you go. If you do not go, then I do not stay. You do not go. So you go is Q. You do not go will be not Q. I do not stay. I stay is P, so it will be not P. Okay, and if then is saying, so that means not Q implies not P. Okay, next is I do not stay. I stay is P. I do not stay is not P. And you go. You go is Q. So if I do not stay, then you go. So direction will be like this. Okay, so I have we just want to say the correct option. A is the correct option, but I have told you all other options also. So what they are saying? So B option is saying P implies Q. C option is saying not Q implies not P, and D option is saying not P implies Q. Okay, and we want converse only. Converse is Q implies P type, so A is the correct option. Okay, and if they say the sentence which is equivalent to the given sentence, then obviously B is the correct option. Okay, if I say equivalent, because this is also P implies Q, sorry, this is also P implies Q, and B option is also P implies Q. Okay, and not Q implies not P. See, if you try to remember, this is contrapositive now, so direct and contrapositive both were same. So if they want equivalent, then two options are correct. Okay, so if you say by your common sense, and if you talk about English language, then you may not be able to prove it. If I stay only if you go, and if you do not go, then I do not stay. So obviously you won't be able to say that both sentences are equivalent. This is the power of logic. So whenever you say two sentences, I can say they are equivalent or not equivalent, or rather I can prove it they are equivalent or not with the help of logic. Forget about sense and all. You are, if you are able to make sense, then it's okay. Otherwise your English is weak. I cannot say anything about it. Okay, so forget about sense and all. You just stick to the logic. Logic is saying they are equivalent, then you will say okay, they are equivalent. That's it. Do not try to think more, or do not try to dig deep into all these kinds of things and all, because it is mathematics, and mathematics is always correct. Okay, you cannot say mathematics is wrong somewhere, because everything is proven, properly proven. Okay, so B and C are equivalent to this sentence. And what about this? This obviously this is nothing. Now this is neither direct, contrapositive, nor converse. It is nothing. So if it was not Q, then I can say it is inverse. Okay, so I hope I have made the point clear to everybody. Okay, and let me show you something here. It is really very important point. Not P implies not Q, na. So P implies Q. Logic is so Boolean algebra style is P bar plus Q. Like this you write. Okay, or in logic itself you can write like this, na, not P or Q. Okay, so these and these are same only. P implies Q and not P or Q. So how you will change it? How you will change it? So not P, na. So not P or Q. So it will be changed as P or Q. So directly, indirectly, I will say like this: I stay or you go. I stay or you go. This sentence and this sentence both are equivalent. Now you keep on thinking about it, they are equivalent or not. I am saying logic is saying they are equivalent, that means they are equivalent. Do not try to think about what sense I am getting and all these kinds of things. This sentence and this sentence both are equivalent. Okay, both are equivalent. This and this both are equivalent sentences. Okay, do not try to dig deep into the English language and all. That's why we say English language is ambiguous language. We are not able to understand the meaning of the sentence and all. Logic is saying they are equivalent. That means they are equivalent. That's it. If I do not stay, then you go, and I stay or you go. They are same sentence. They are equivalent sentence. So I hope I have made the point clear. Please take snapshot or something. I will jump to the next slide. Okay, so you keep on thinking day and night, still you will not be able to say they are equivalent sentences, but actually they are equivalent. Why? Because logic is saying they are equivalent. Okay, let me jump to the next slide. So I think you already know the history of logic. Na Aristotle in some I think I do not remember the year, in some BC, Aristotle invented this logic so that he can prove that whatever his teacher has said, that was correct. Okay, so the main aim of logic is to prove that something is true or false. That's it. Okay, so let me jump to the next slide now. Okay, 2002 question. If x and y, if x then y unless z in logic, they want to say which of the in logic, what is the meaning? If x then y unless z. So first of all, this thing, if x then y, unless I have told you, it is just like or z. So now question arises, I have converted it, but what exactly it will look like? For example, I can say x imply y or z like this, or x imply y or z like this. I do not know which is correct, which is wrong. So for that, I have written here precedence. So bracket is having most precedence, then not, then and, then or, then implication and double implication. So or is having more precedence. So this thing is correct. This thing is correct. Okay. X imply Y or Z. This is correct. So now see the option X imply Y or Z. So you are not having that option. So you have to change something. Okay. So let me try to change it. Okay. So what I can say. So X bar. Let me say it in Boolean algebra style. So X bar plus Y plus Z. That is the scenario. Okay. So now see the options what they are saying. X and not Y implies Y, X and Y implies not Z, and so on. So let me change them also, because only then I can prove what is correct and what is wrong. So let me change it. So how it will look like: X dot Z bar whole bar plus Y. So it will be X bar plus may Z plus may Y. Same scenario. So A is correct option. I hope I have made the point clear. Similarly, if you try to expand it, what you will get? X bar plus may Y. If you expand it, X bar plus may Y and then plus may Z. By chance, they are getting equal. By chance. Okay, sometimes they may not be equal. So you have to remember this precedence rule. What precedence rule is saying? Bracket is having highest precedence, then not, then and, or, implication, double implication. Like this you have to remember. So implication is having less precedence than or. Okay, so better is you follow this thing. This is correct. By chance they are getting equal answer, but sometimes they may or may not get answer. Okay, and if you try to expand it, what you will get? What you will get? X and Y implies not Z. So X Y whole bar plus Z bar. Like this. I think you remember na P implies Q is P bar plus Q na. You remember na P implies Q is nothing but P bar plus Q in Boolean algebra. So try to change like this. So this is the twist in gate exam na. They will do not say directly. See, if they have given this option or they have given this option, you will immediately say okay, this is correct. But they will slightly twist the question. Okay, so they will try to form an equation or option which you may think that it is not available and such kind of things. Okay, so better is you try to do one more step and you will get the answer. I have told you many times that gate exam questions are maximum 2 to 3 steps. So one step is this, one step is this, you have got it. Second step is this is correct. Okay, now we have got the option, but it is not matching. So now try to manipulate them. So third step. So maximum 3-step question. That's it. Okay. Yes. So similarly, you can expand this also. So X bar plus may Y Z bar. Okay. So and you can expand it also. X bar plus may Y dot Z bar, like this. Please try to apply the brackets, otherwise you will get confused here. So X bar plus may Y dot Z bar. So obviously A option is correct. Okay. Now please take snapshot. I will jump to the next slide. Yes, I'm jumping now. A 2017 question. Let P, Q, R denote the statement it is raining, it is cold, it is pleasant respectively. So P is what? It is raining. Q is what? It is cold. R is what? It is pleasant respectively. Then the statement it is not raining. It is not raining. Raining is P na, so not P. It is not raining is not P. And it is pleasant. And it is pleasant. So what is pleasant? R and R. Okay. And it is not pleasant only if it is raining and it is cold. So now see this, only if has come. Only if means what? Implication. Implication, only if direction was from left to right. So it is not pleasant. So it is not pleasant means what? Yeah, so not R. Not R. Okay. Not R. And then uh, it and it is not pleasant only if it is raining and cold. It is raining. It is raining is P. Cold is Q. So and is there na? So like this. So I will say like this. Okay. So it is not raining and it is pleasant, comma, and it is not pleasant. Okay. Only if it is raining and it is cold. Yes. So finally we have got it. So comma means and it is not yes. So I have written and. So I will apply here and it is not pleasant only if it is raining and it is cold. And so and right. If you have any doubt, please let me know how I have changed it. So let me draw it again. If you have any doubt, let me draw it again. Okay. So P is what? It is raining. So what is the sentence? It is not raining. It is not raining means not P. And it is pleasant. And it is pleasant. It is pleasant is uh, R. Okay. Then and. Okay. And it is not pleasant only if means implication. It is not pleasant. It is not pleasant is R. Implies what? It is raining and it is cold. Raining and cold. Raining is P and cold is Q. P and Q. That's it. So now you try to apply brackets. Okay. Finally, we have got it.
So not raining, R, not R.
It is not raining.
It's not pleasant. Second part, sir. After and, it's not pleasant. Yes.
Is it okay now?
Yes, sir.
So note R we will write. Okay, so finally we have got it. So now try to match the option not P and R and not R implies P and Q. A option is correct. That's it. Okay. Yeah. So this is our final answer. So I hope I have made the point clear to everybody. Yes, please take snapshot. I will jump to the next slide. I am jumping now. A 2014 question. Good mobile phones are not cheap. Cheap mobile phones are not good. So now you have to draw some common sense. See, I am saying good mobile phones are not cheap. So indirectly what I am saying is, if mobile phone is good, then it is not cheap. Are you getting it? Try to make sense out of it. If good mobile phones are not cheap, this is a general statement. So general statement means what? Good mobile phones are not cheap. That means what? If mobile phone is good, then it is not cheap. So good mobile, let us say it is say X, okay, and cheap is say Y. So I will say X implies not Y. Are you getting it? Good mobile phones are not cheap. So good mobile phones I am taking as X. Good mobile phones I am taking as X. Not cheap. Cheap I am taking as Y. So X implies not Y. Okay. So now see this cheap mobile. Cheap I am taking as Y. So cheap mobile I will be taking as Y. Na? Okay. Cheap I am taking Y. So not cheap was not Y. So cheap mobile is Y only. Are not good. So cheap mobile phones are not good means what? If mobile phone is cheap, then it is not good. Okay. So this is the general perception of everybody. Na? If mobile phone is cheap, then it is not good. So implies good mobile is X. Na? So not good means not X. Are you getting it? So it's up to you, whatever you take. If you take this entire thing as X and not cheap as Y, then obviously you will say cheap as not Y. Okay, it's up to you, whatever way you want, you can take. So X implies not Y, Y implies not X. So these are the two things, P and Q, these are the two statements. P statement is this, Q statement is this. So now they are saying P implies Q, Q implies P is equivalent to Q. Which is true, which is false. So this implies this implies this. What is true and what is false, I want to prove it. So now if you think carefully, if you have done good practice, you will immediately say, see, I have told you, na, P implies Q and not Q implies not P. They are equivalent. I have told you many times. This is contrapositive. Na? P implies Q, contrapositive is not Q implies not P. So now see here, X implies not Y. Contrapositive will be what? You will not it will become Y. And change the direction, na? And you will say not X, so you will get this. So they are contrapositive for each other. So indirectly, they are equivalent. Now, since they are equivalent, this is the twist in the question. Now, in GATE exam, you will say, okay, they are equivalent, and so you will take only N. N is correct. But actually, it is wrong. Why it is wrong? That's why they have given multiple options. Now, see, when P and Q are equivalent, so obviously, I am saying like this, P double implication to Q. So directly, indirectly, what I want to say is P implies Q and Q implies P. Both are true. Only then P double implication to Q is true. Huh? Are you getting it? So when both are equivalent, so I can say na that this thing implies this thing, or this thing implies this thing. One and the same thing only. So P double implication to Q. So that means what P implies Q and Q implies P both should be true. Only then P double implication to Q is true. Okay, I think I have told you many times in truth table and all these kinds of thing in the previous lecture also. Okay, so no problem. So finally, this is also true. P implies Q and Q implies P is also true. So directly, indirectly, P implies Q is true. Q implies P is also true. And P is equivalent to Q. This is obviously true. So first I have proved this thing. This is true. Now from that I have concluded that this and this are also true. So finally, correct is what? Only L, no. Only N, no. Only M, no. L, M, and N, all are true. So D is the correct option. C is incorrect, A is incorrect, B is incorrect. D is the correct option. And almost 99% of the students have done it wrong in GATE 2014. Just because they have said equivalent, so only N is true. Many of the students pick only C as the option. Very few take L, M, and N. The option, very few take. So I hope I have made the point clear. How I have solved it, I think you have got it. If anybody is having any doubt, please let me know. Okay, so I hope everything is clear. Please take snapshot. I will jump to the next slide now. Okay, now I'm jumping. A 2016 question, but it is saying P is X belong to 8, 9, 10, 11, 12. So X can be anything. Okay, so see this. This is a set, and X belong to this set. So that means what? X can be either 8, 9, 10, 11, 12. It can be anything. Now I am saying Q is X is a composite number. Composite number means that it is not prime. So not prime means what? Q is saying X is either 8 or 9, 10 or 12. This is what Q is saying. R is saying X is a perfect number. Perfect number means what? Perfect number is whose I think you know na that 6 is a perfect number because sum of its factors is same as the number itself. So 1 plus 2 plus 3, that is same as 6. So factors of 8, 9, 10, 11, 12, I think you can check it out. None of them is perfect. Now next is saying X is prime number. So it is saying nothing is here. X is prime number. Prime number means see what are the prime numbers? Only 11 is the prime number. Okay. So now I am saying integer X is greater than 2, greater than equal to 2, which satisfy this entire equation. So now if you try to get this entire equation, obviously you will get confusing GATE exam. So better is try to minimize it first. If you try to minimize it, you will immediately get the answer and very easily you will get the answer. So see this. So how to minimize it? I have told you many times. You just convert it into Boolean algebra and try to solve it. You will get the answer. So P implies Q is what? P bar plus Q dot R bar plus में S bar. R bar plus में S bar. And whole knot, that means what, like this. Okay. Please try to apply brackets, otherwise there will be a problem. So P bar plus में Q dot R bar plus में S bar whole bar. So now try to solve it. So what it will become? P bar plus में Q whole bar plus R bar plus में S bar whole bar. So finally, what it will become? R double so RS. It will become RS. I think you can check it out from your De Morgan's law. You will get it. Plus P Q bar. Okay. So P Q bar plus में RS. This is the answer what I am getting. So P Q bar plus RS. So P is what? X belong to these numbers. Okay, and Q bar is what saying? X is a composite number. So directly it is saying X is a prime number. Okay, Q is saying X is a composite number. So Q bar means what? Q bar means X is a prime number. Opposite of composite, prime number. Okay, so what can be that? So we will get answer as from here. What is the prime number? So P should be satisfied. That means what? X should belong to this. And Q should be satisfied. That means X is a composite number. So which number should be that? 11. Plus means what? Union. So now you want to add something extra. R and S. R is perfect number. No, there is no perfect number here. Okay. X is a perfect number. Okay. Let me say it like this. So please do not try to link it with P. You just say like this. X is a perfect number and X is a prime number. So perfect number as well as prime number. I cannot have any number which is perfect as well as prime number. So it will give us nothing. So finally 11 is the answer. Okay, I hope I have made the point clear. So answer to this question is 11. Okay. So see this. Actually, you can say try to link all these things P and Q. X is a composite number means X can be any number. It may or may not be belonging to it. Okay, so please do not get confused here. I should rub all these kinds of things so that you get more clarity. These are the statements. P is saying X belong to this. So X can be any of this number. Q is saying X is a composite number. So it can be any number. Okay, but it should be composite. That's it. R is saying X should be a perfect number. S is saying X is a prime number. So these are the statements. So now this is the given to us integer X is greater than or equal to 2, which satisfies these things. So I minimized it and finally I have got it PQ bar plus में RS. So PQ bar means what? P should be satisfied and Q should not be satisfied. And so P should be satisfied. That means what? X should belong to this and X should be a prime number. Opposite of composite is prime number. So what is that? So 11 is that number. Okay. So finally we have got 11. Now R and S. So perfect number as well as prime number, that is not possible. Okay. So obviously we will get nothing from here. Okay, so you just try to think of a number. Do not think about all these numbers only. You just think about any number. Okay, so what perfect also, prime also. That is not possible. So empty. So finally 11 is the answer. That's it. Now please take snapshot. I will jump to the next slide. Okay. I'm jumping to next slide now. Yes, so now we are going to start biconditional or double implication. So next operator I am going to start. Okay. So in logic we say PQ and P double implication to Q. So in logic we will say false, 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 true, true, false, true, true. So in logic we will say true, true, false and false. Double implication means equivalent. So P and Q should be equivalent. So when they will be equivalent? When both are false or both are true. In case of Boolean algebra, I have told you many times, double implication is same as X NOR. So it is X NOR. Na? So see this. In Boolean algebra, I will say 0, 0, 0, 1, 1, 0, 1, 1. So 1, 1, 0, 0. So in logic, double implication and in Boolean algebra, X NOR. Both are same thing. Yes, so this is biconditional or double implication. Yes, let me jump to the next slide now. Please take snapshot. Okay, I'm jumping now. So see this. I have told you just now. If P implies Q and its converse Q implies P, both are true, then P double implication to Q is true. Let me prove it now. That why it is true. See this. False, 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 true, true, false, true, true. P double implication to Q will be true, true, false, false. P implies Q, true, true, false, true. Q implies P, true, false, true, true. And when we do AND of these two, what we will get? True, false, false, true. So now see this. This and this. Exactly same. That's why I have said if P implies Q and its converse Q implies P, both are true, then P double implication to Q is true. And application of this thing I have already given you in this question. I have given application of this in 2014 question already. Okay. Please take snapshots, and if you have any doubt, please let me know. These are very basic things. Na? Q implies P, how you will check it out? So Q true and P false, that should not be done. So Q true, P false, that should not be done. So it is false. Rest everything is true. I think you have got it. These are very simple things. If still you have any doubt, please let me know. Otherwise, I will jump to the next slide. Okay. So yes, I'm jumping to the next slide now. So now we will do translation. So for implication, I have done translations. Total 10 translations I have given you. P when Q, Q when P, and so on. Whenever P is sufficient for Q, Q is necessary for P, and so on. I have totally given you 10 translations. So now I'm going to give you translations for double implication. Okay, for double implication, I'm going to give translation. So first translation is if and only if, and we call it as I double F also. I double F or if and only, one another same thing. So I will say you can take flight, you have ticket. P and Q is this. So P double implication to Q. What you will say? You will say in English. You will say you can take flight. You can take flight if and only if you have ticket. Okay, or you can say directly like this also. In place of if and if, I double F, you can say directly if and only if. If and only if. Let me write it properly. If and only if you have ticket. Okay. So I have just changed it. That's it. So in GATE exam, if you find this kind of question, you can take flight if and only if you have ticket. So how you will change it in logic? Logic formula will be P double implication to Q. I hope I have made the point clear. And if you want me to prove that why if and only if is double implication, let me show you something. Let me show you something. So I will say if P, okay, or let me say like this, Q if P, okay, okay, let me say P if Q and P only if Q, if I say like this. So directly, indirectly, what does this mean? P if Q and P only if Q. So it is nothing but P if and only if Q. Are you getting it? In English, I have got it. Na? P if Q and P only if Q. So I can say P if and only if Q. So now change it. P if Q. So it will be like this. So Q implies P. And I have used and. P only if Q. Direction was like this. Easy. So I have told you, na, Q implies P and P implies Q. Whenever both are true, that means what it is nothing but P double implication to Q. So I have got it like this. So this is the proof that why if and only if is double implication. Okay. Yes. Please take snapshot. I will jump to the next slide. Okay, I am jumping now. So P next is P is necessary and sufficient for Q. Okay, that is this is also meaning of P double implication to Q. Why this is true? I can say like this. I will say P is necessary for Q. P is necessary for Q and P is sufficient for Q. So P is necessary for Q. So direction will be what? Like this. P is sufficient for Q. Direction will be like this. So it will say Q implies P and P implies Q. So I have already told you it is nothing but double implication. Double implication. So this is the proof that P is necessary and sufficient for Q. Why this is like that? Okay. So yes, so if you want me to give you example is same only. You can take like this. You can take flight, you have ticket. So a necessary and sufficient condition for taking a flight is you have a ticket. I can say like this. So it's English, na? You can mold it anyway. So I can say like this: necessary and sufficient condition. Necessary and sufficient condition to take flight is that you have ticket. So directly, indirectly, this sentence means what? Since it is necessary condition for taking flight is you have a ticket. So what does this mean? Necessary condition means when necessary condition is false, you will not, your hypothesis will be false. So I will say necessary condition for to take a flight is you have a ticket. So if you do not have ticket, you cannot take a flight. This means like this. Sufficient condition to take a flight is you have a ticket. That means that if you have ticket, you will definitely take a flight. So directly, indirectly, I want to say if you have ticket, you will take a flight. If you don't have ticket, you will not take a flight. That's it. Yes to yes, no to no. That is the basic way. If you have any doubt, please let me know. And same is the scenario here also. If and only if, you can take flight if and only if you have ticket. So if you have, you can take, if you are taking flight, that means you have ticket. And if you have ticket, that means you are taking flight. So both ways you have to see. Okay, that is the basic meaning of if and only if. Okay, so necessary condition means what? When necessary condition is false, hypothesis is false, na? So if you do not have ticket, you cannot take a flight. Okay, no ticket means no flight. That is the basic meaning of necessary condition. False for false, necessary. Sufficient means true then true. So if you have ticket, you will definitely take a flight. That is the basic meaning. Okay, please take snapshot. I will jump to the next slide. If you have any doubt, you can ask me. Otherwise, I will jump to the next slide. Okay, so I'm jumping to next slide now. So double implications. Now see this. I have only shown you 2 translations only. Okay. So in implication, I have shown you 10 translations, but in double implication, only 2 translations. Why? Because in implication there was direction case. Okay. So like here, like this, and so on. Direction, according to direction, I was changing. But in double implication, there is no direction rule because it is both ways. It is both ways. That's why only 2 translations I have shown you. See this. Double implication only 2 ways, but implication 10 ways for translation. Why this is the case? See, because in implication both all these 4 were different. This was known as direct, this was known as converse, this was known as inverse, and this was known as contrapositive. Okay, so I am see first is this P implies Q. I have changed the direction. I have got converse. When I applied not on both, I will get inverse. When I change the direction as well as apply the note, I will get contrapositive. Now same scenario I am doing here. P double implication to Q. I am changing the direction. I will get it. Okay, so that means it should be converse. It should be converse. It is direct. It is converse. Now what I am saying, I am taking inverse. Why? Because I am just applying not on all both. That is inverse, and this should be contrapositive. But actually, and I have told you now, this and this were equivalent. This and this were equivalent. By logic, I have already proved you all these kinds of things. From Boolean algebra also, I have told you that they are equivalent and they are not equivalent, and so on. This and this were not equivalent. I have told you. Okay, so here actually all are equivalent. That's why we do not name them. Direct, inverse, converse, contrapositive. There is no name of all these things because all are equivalent. All are equivalent. Okay, so since all are equivalent, so there is no question of making other direction kind of thing and all. So there are only 2 ways here. Yes. So please take snap, and this is very important point. Please try to follow it. P implies Q, P double implication to Q, Q double implication to Q, P and so on. Why these all are equivalent? So you can prove it by Boolean algebra also. Like this, I have proved all these things by Boolean algebra. Okay, I can also prove it by Boolean algebra. I will say like this: P X nor Q. Okay, Q X nor P. Both are same. Why? Because X nor was commutative. I have told you. And P bar X nor Q bar or Q bar X nor P bar. All were same. Now see this P and Q similarity is. So in complements we are doing finding similarities. So directly indirectly in actual also we are finding similarities. If you try to follow, if you are not able to follow, please watch my previous lecture. I have told you. Okay. So when I was discussing properties, now I have told you these and these are equal. Are you getting it? Na? P X nor Q, that was same as P bar X or Q. I think you are getting it. I have told you many times like this. Please watch my previous lecture if you are not able to follow. So this is the proof that P X nor Q, Q X nor P, P bar X nor Q bar, Q bar X nor P bar, all are same. All are same. Okay. From Boolean algebra, I have proved all these things. Okay. Let me jump to the next slide now. I think everybody has taken snapshot. I'm jumping now. So find the logical expression for this thing. This is the question. P is necessary but not sufficient for Q. Okay. P is necessary. So directly what I want, but means what? And you have to remember it. In logic, but means and. So I want to say is P is necessary for Q and P is not sufficient for Q. So since P is necessary for Q, so direction will be like this. Sufficient, direction will be like this. Now P is not sufficient for Q. Okay. So now see this. This is a very important point. See this. Yes. So first, before studying this question, see this. not P is sufficient for Q and P is not sufficient for Q. Are these two equivalent sentences? What do you think? Not P is sufficient for Q and P is not sufficient for Q. Are they equivalent? No, they are not equivalent. How you will prove it? Please do not apply common sense here. You have to do it by logic. Not P is sufficient for Q. Sufficient means like this. So not P implies Q. Now I have told you that not is having more precedence. So you will say like this. Not P implies Q. And what is this? P is not sufficient for. Sufficient direction is like this. So P is sufficient for Q is this. Now I am saying P is not sufficient for Q. So I will apply not like this. So obviously they are not equivalent. Please try to follow it. Okay, by English you will say not P is sufficient for Q or P is not sufficient for Q, one and the same thing and so on, but they are not equal. I have proved it by logic. Not P is sufficient for Q is not P implies Q. And what is this? P is not sufficient for Q. If I say P is sufficient for Q, you will say P implies Q. I am saying P is not sufficient for Q, you will apply not, and for entire this you have applied not. Okay, so both are not equivalent. Okay, so now see this. P is necessary for Q, but means and. P is not sufficient for Q. So I will say P is necessary for Q. Q implies P, like this. And P is not sufficient for Q. Not P implies Q, like this. So now you can solve it and get the answer. What a big deal is this? So you can do by Boolean algebra and so on. Let me do it. P Q bar plus में P dot P bar plus में Q entire bar. I think you have got it, na? P bar plus में Q whole bar. So now you try to solve it. Q bar plus में P dot PQ bar. PQ bar. Okay. I have just changed it. By De Morgan's law, I have just changed it. P dot Q bar. So now PQ bar dot Q bar, it will be PQ bar only, and plus में PQ bar dot P, it will be PQ bar only. So finally, we will get PQ bar only. So P and Q, P and not Q, I am getting. Right. This is my final answer. Okay. So formula for this will be like logical expression for this will be P and not Q. P is necessary but not sufficient for Q. So I hope I have made the point clear. Please take snapshot or something. I will jump to the next slide now. Okay, I am jumping now. Now please take snapshot of this also if you have not taken it. Okay now. Yes, so next is find logical expression for P is sufficient but not necessary for Q. So same thing, I think you can do it, but is and, but in English and in logic, one and the same thing. P is sufficient for Q. P is sufficient for Q and P is not necessary for Q. So P is sufficient for Q, direction is right. P is not P is not necessary for Q. P is necessary for Q. Direction will be like this. So Q implies P whole not and P implies Q. Like so nothing. I think you can solve it. I should not waste time here. I am leaving as homework for you. You can minimize it by Boolean laws and you will get the answer. Okay. Please take snapshot. I will jump to the next slide. I am jumping now. So what is the application of implication and double implication in mathematics? If double implication is used for two-way theorem and implication is used for one-way theorem, they are very, very important. One-way theorem are very important because in GATE exam you will find many true-false questions, and all these true-false questions can be answered from one-way theorem only. Okay, so let me show you something about two-way theorem first. So I say, see, I think you have heard about Pythagoras theorem and all. So if x square plus y square is equal to z square, then triangle is right angle. This is one. This is first, you can say statement. Second statement is if triangle is right angled, then x square plus y square is equal to. Sorry, if triangle is right angled, then x square plus y square is equal to z square. So see, if this is P and this is Q, so this will be Q and this will be P. So what first statement is saying? P implies Q. What second statement is saying? Q implies P. both are true, na? So P implies Q and Q implies P, both are true. So finally, what conclusion I can draw? P double implication to Q. So finally, these two statements can be written like this: x square plus y square is equal to z square if and only if triangle is right angle. Or you can write like this also: triangle is right angled if and only if x square plus y square is equal to z square, and so on. So obviously 4 ways you can write it. In the next slide I will show you all the 4 ways. Okay, so finally we have got it, P double implication to prove. Example. So if somebody wants to prove Pythagoras theorem, then what it has to prove, or what he or she has to prove, this also and this also. If you are able to prove both things, then you will say Pythagoras theorem is true, because Pythagoras theorem is saying if and only if kind of thing. Okay, that is the basic meaning of two-way theorem. Whenever you say I double F or if and only if, that means both way you have to prove. Okay, so this is an example of two-way theorem. Let me jump to the next slide now. Please take snapshot. Yes, I'm jumping now. So yeah, two-way theorem, I have explained it. So I'm not writing right angle triangle. I have just made right angle triangle just to save the time. So x square plus y square is equal to z square if and only if triangle is right angled. This statement is 100% true. Triangle is right angled if and only if x square plus y square is equal to z square. This is also true. Now x square plus y square is not equal to z square if and only if triangle is not right angled. This is also true. And triangle is not right angled. This is not silly. Now triangle is not right angled if and only if x square plus y square is not equal to z square. This is also true. Okay. So since it is both ways, so that means what? If this is true, this is true. If this is false, this is false. That is the basic law. Okay, let me show you. Both ways means if and only if means when this is true, x square plus y square is equal to z square, this is true, then triangle should be right angle. This should be true. And when this is false, then this must be false. Okay, true implies true, false implies false. And this also, if I am saying triangle is right angled, this should mean that x square plus y square is equal to z square. And when I am saying when triangle is not right angled, that means x square plus y square should not be equal to z square. Are you getting it? These 4 points are very, very crucial for you to understand these two-way theorem. So what exactly this is saying? When x square plus y square is equal to z square, then triangle should be right angle. So when this is true, this should be true. And when this is false, this should be false. X square plus y square is equal to z square. If this is false, that means what? X square plus y square is not equal to z square, then triangle should not be right angle. Same scenario here. When triangle is right angled, then x square plus y square is equal to z square should be true. And when triangle is not right angled, then x square plus y square should not be equal to z square. Okay, I hope I have made the point clear. Okay, now please take snapshot. Everything is on one slide. You can take snapshot. And this also you can take. So all these statements are true. Okay? Because I have told you in P double implication to Q, nothing is like converse, inverse, contrapositive, all are same. Okay? I hope I have made the point clear. Please take snapshot. Okay, now. So what is the example of one-way theorem? I am saying like this: if theta is equal to 90 degrees, then sin theta is equal to 1. I think you already know from trigonometry. So this is a one-way theorem. So now I have written four questions: 1, 2, 3, and 4. So theta is equal to 90 degree implies sin theta is equal to 1. This is 100% true statement. I have told you this only. I have just converted into logic. What is this? Sin theta is equal to 1 implies theta is equal to 90 degree. Can you conclude that if sin theta is equal to 1, then theta is equal to 90 degree? No. You can add 2 pi to it. 2 pi plus pi by 2. 5 pi by 2. That is also sin theta is 1 there also. So this statement is false. If theta is not equal to 90 degree, then sin theta is not equal to 1. No. So theta can be 5 pi by 2. And in that scenario, sin theta will be 1. So this statement is also false. What is this? Sin theta is not equal to 1 implies theta is not equal to 90 degree. Okay? Yeah, this statement is 100% true. Why? Because this is contrapositive of this. When sin theta is not equal to 1, obviously theta is not equal to 90 degree. Okay? Yes, so I think you have got it. So this and this are equal, this and this are equal. So if I say like this, P implies Q, this is P implies Q, and this is what Q implies P, and this is what not P implies not Q, and this is what? This is not Q implies not P. Okay, so why these are direct? This is contrapositive. Direct and contrapositive are same, and converse and inverse are same. This is converse and this is inverse. Converse and inverse are same. Now I think you have got the idea, na? Why converse and inverse are same? Because sin theta is equal to 1 is, implies theta is equal to 90 degree. I cannot conclude it. Similarly, theta is not equal to 90 degree implies sin theta is equal to 1. Sin theta is not equal to 1. That is again same thing. Okay, so converse and inverse are same. Yes. Please take snapshot or something. I will jump to the next slide. Okay, I'm jumping to the next slide now. So now we will study few keywords for the translations. Okay, and you have to by heart them. They are very, very important. Many times questions have been asked in GATE from these. So I have told you in the previous slide also, but in English and in logic both are same. So but will be treated as and in logic. So I am saying sun is shining, but grass is wet. This was the English sentence. But when I convert it into logic, I will say sun is shining P and grass is wet is say Q. So I will convert it into logic like this, P and Q. See, actually you may be wondering that why but is treated as and. There is no way out in logic. See, I cannot uh, uh, give you some expressions in logic. That's why logic is incomplete. What exactly from common sense, what you are saying, sun is shining. So your expectations was grass should be dry. It should not be wet. But still I am saying grass is wet. So it's against your expectations. So in logic, there is nothing called expectation. Okay, logic is straightforward, black and white. That's why logic is called black and white. There is no gray kind of thing in logic. There is no may or may not kind of thing in logic. There is either true or false. That's it. So I'm saying sun is shining, but grass is wet. There, your expectation was grass should be dry, but still it is wet. That's why I'm saying sun is shining, but grass is wet. In logic, you are saying P implies Q. So in logic, it should be sun is shining and grass is wet, like this. Okay, there is no expectation kind of thing. So according to logic, this English sentence and this sun is shining and grass is wet. Both are same. Both are same according to logic. Okay, but you know that this sense and this sense is different. The sense which you are getting from this sentence and the sense which you are getting from this sentence are different. Okay, but logic cannot copy these kind of things. That's why we say logic is incomplete. It is not complete thing. Okay. Yes. So now please take snapshot. I will jump to the next slide. Okay. I'm jumping now. Nevertheless is same as and. Okay. Nevertheless in English and in logic and one and the same thing. So I didn't study for exam. Nevertheless, I passed. So you are wondering that I did not study it, but still I passed. But in logic, I will say like this: I study for exam, or I did not study for the exam. You take it as P, and I pass. You take it as Q. I will say P and Q. In logic, it is like that. There is no expectation kind of thing in logic. So you have to by heart all these things. Okay. So nevertheless is just like and. Please take snapshot. I will jump to the next slide. Okay, I'm jumping now. Unless will be treated as or. I think I have told you many times. Unless will be treated as or. So P unless Q is same as P or Q. Okay. And now please tell me P if not Q, how it will look like. P if not Q. So now see this. P if we say P if Q, so direction was like this. So if I am saying P if not Q, so same not Q. If so the direction will be like this. So not Q implies P, like this. Not Q implies P. I think you have got it. Not Q. Not Q. You will treat it like this. Not Q implies P. Okay. And you already know, not is having more precedence than implication. So not will be, so we will apply bracket here. Not Q implies P. Okay. So now how it will look like if you draw it in Boolean algebra kind of thing. So it will be not q bar bar plus p. So it is nothing but q plus p, and that is nothing but p plus q. So it will be same as p or q. So p if not q or p unless q, both are one and the same thing. Why they are same? I am not saying they are same. Logic is saying they are same. That's why you have to say they are same. Do not try to find any kind of meaning or and kind of thing like this. Okay, you have to say they are equal. That's it. Okay, so I think I have proved it. If anybody is having any doubt, please let me know. You have got it now. Not q implies p. So q bar bar plus p. Okay. Because p implies q is what? E bar plus q. Na? So if I apply not here, so it will be bar here. So I think you have got it. Okay. Please take snapshot. Yes. Yeah. Please take snapshot. I will jump to the next slide. Okay, now. So now see this. This is the beautiful thing. This is the logic. So now see this. Don't promise anything unless you are 100% sure. And the sentence is, if you promise anything, then you should be 100% sure. So I am saying that are these two sentences equivalent? It's my humble request to all of you, whenever in GATE exam you find such kind of question, do not try to make any kind of sense out of it. You just try to say this kind of thing. Okay, so you just try to do it by logic only. So promise anything. Okay, promise anything. Or you can take don't promise anything. Whatever way you want, you can take. I'm taking it as P. You are 100% sure. You are taking it as Q. Unless it's or, na. So logic conversion for this is P or Q. And what about this scenario? If you promise anything, then you should be 100% sure. If you promise anything. So, okay, I think promise anything. Na? So don't promise. So not P or Q. Sorry for that. Promise anything was P. So I have said, na, don't promise anything. So not P. Okay. You are 100% sure is Q. So not P or Q. It will be not P or Q. Now what is this? If you promise anything, then you should be 100% sure. So promise anything was P, na? This is P, and you should be 100% sure it is Q. So if P then Q, P implies Q. P implies Q is nothing but not P or Q. So obviously both are equivalent. This statement is true. So like this you have to judge in GATE exam. Okay, don't promise anything unless you are 100% sure. And if you promise anything, then you should be 100% sure. Both are same thing. I am not saying it. Logic is saying it. So you have to believe that both are same. Do not try to make any kind of sense out of it. Please take snapshot. I will jump to the next slide. I'm jumping now. So children are allowed to enter park. They are with parents. So this is MSQ question. Okay, multi-select question. So more than one option can be true. So now translation is, children are not allowed to enter park unless they are with parent. So children are allowed to enter park is P. So children are not allowed to enter park. Children are not allowed to enter park. That is what? Not P. Unless is or. They are with parents. They are with parents is Q. So not P or Q. So not P or Q I am getting. So P or Q. Clearly it is false. Okay. Children are allowed to enter park, I have said, na? Okay. So this is not P or Q I am getting. So P or Q is false. So not P or Q is just like P implies Q. Okay. So P implies Q. So I'm not getting any kind of thing also. So but I'm getting here as not P implies Q. So I'm getting P implies Q. So obviously they are not equal. Not Q implies P if you say this. So what is not Q implies P? So Q bar bar plus P, that is nothing but P or Q like this. But I'm getting not P or Q. So this is also false. So none is correct. Okay. So now if I change this question a little bit, you will get more clarity. Please take snapshot. Okay. Please take snapshot. I think you have taken. Now I'm saying children are okay. Let me copy this slide. You will get more clarity then. Here is the slide. Yeah. So now I will show you here itself. So now I will say, I think you have, everybody has taken snapshot of this. Now I am saying you another question. Now I will say, children are not allowed to enter park. Okay. And now what you will say now? Now please tell me what will be the answer.
So option B.
Okay, let me check. Children are not allowed to enter park. They are with parents. Okay, so what will be this? This will be P. Children are not allowed to enter park. This is also children are not allowed to enter park. So it will be P. Unless is or okay, and they are with parents is Q. P or Q. So obviously A option is correct. Now what about this scenario? Not P implies Q. Not P implies Q will be what? P bar bar plus Q. So P or Q only. So one and the same thing. Not Q implies P. I have told you P or Q only. So all the three are correct. That is the beauty of MSQ. Okay. Now please take snapshot. I will jump to the next slide. Now beauty of MSQ is do not get excited in GATE exam. P or Q you are getting A option is correct. That's it. Please try to check other options also. They may be correct also. And by chance they are correct here also. Okay. I'm jumping to the next slide now. Next is either P or Q. So if we say either P or Q, you will treat it as or only. Okay, but unfortunately, many teachers and other in YouTube and all, you will find that they will say that they are. It is just like XOR. No, it is not like XOR. Okay, it is just like or only. So if I say either I take bus or I take metro to reach office, so you will immediately convert it into like this P or Q. I take bus is P, I take metro is Q. So either I take bus or I take metro to reach office, P or Q. That is one and the same thing. So now, if you try to make sense out of it, you will immediately say, "Nah, I can take either I take bus or I take metro to reach office." Sense is that you can take bus or metro both to reach office also, like half of the way by bus and half of the way by metro also. Okay, so or is like this. Now, if you want to say clearly, then you will say, but not both. If you say like this, but not both. If this line is also written in the question, then you will say it is nothing but Px or Q. Only then you will say it as Px or Q. Exclusive of. That means either this is true or this is true. Both are not true at the same time. Okay. Now here both can be true at the same time also. Okay, but not both is there, then you will say Px or Q. But not both is not there, then you will say P or Q. Okay. So I have clearly written here. Don't consider it as XOR. For XOR clearly say but not both. Okay. Hence, do not draw any sense from logical sentences. Do not draw any kind of sense. Let me show you one more example. But what I want to say here, what do you mean by sense? Like this, I can say Modi will be PM. Q is today train. So what is Q implies P? Q implies P is if today it rains, then Modi will be PM. What is the sense out of it? It's meaningless sentence. But if you say it is logical, I will say 100% it is logical sentence. It is a logical sentence. Okay? Because I have just changed it. This was a proposition. Modi is PM. Today is rain. Yeah, it is also proposition. And I have just made a compound proposition. If today it rains, then Modi will be PM. That's it. Okay, so do not try to make any kind of sense out of logical sentences. Okay, so directly and indirectly, this P and Q are not related to each other. Do not try to relate them or do not try to make any kind of sense out of them. I have just, you can say, combined these two sentences. That's it. Okay, but the sentence which we have made is a totally weird kind of thing. But anyhow, that's it. This is the basic thing. Now, please take snapshots. I will jump to the next slide. Okay, I'm jumping now. Next topic is arguments. See, we are jumping to the new topic, that is arguments. What argument is saying? So we have some propositions like P1, P2, P3, dot 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 up to Pn. We have some propositions. Now from these propositions, I will try to draw a conclusion. That conclusion is also a proposition. Okay. So this entire thing is known as argument. So argument means we have some propositions. From these propositions, we will try to draw a conclusion. Okay. So we will assume, this is a very important point, we will assume that all these propositions are true. If we assume that all these propositions are true, then from these propositions I will try to draw a conclusion. Okay, this entire thing is known as argument. So this is, I have written, we have n propositions. Propositions are also known as premises, and from these we will try to draw a conclusion or inference. Okay, conclusion or inference. This entire thing is known as argument. Okay. So another way of writing argument is like this: P1, P2, P3 up dot 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 up to Pn. Okay. And this symbol is known as turnstile symbol, and this is the conclusion which we are drawing. So you can represent argument like this also, or like this also. One and the same thing, no problem. Let me show you some example. You will get more clarity. Okay. Like this, you will not be able to follow because this is a theoretical thing. Let me show you something. I'm jumping to next slide now. Okay, yes. So this is an example of argument. I am saying if it rains, children will not play. I am saying it rains, therefore children will not play. This is a conclusion. So this is premise. You can say proposition number 1. This is proposition number 2. And now this is the conclusion. Conclusion is represented by therefore. Therefore, so I have written conclusion is children will not play. Okay, so this is an example of argument. So argument is I have propositions, or and I am assuming that they are true. I am saying if it rains, then children will not play. I have said this thing to you. If it rains, children will not play. And then second proposition, I am saying it rains. So what conclusion you will draw? Obviously, children will not play. This is an example of argument. Please take snapshot. I will jump to the next slide. Okay. So argument can be valid or invalid. Okay. When can I say argument is valid? Okay. When can I say argument is valid? When conclusion is drawn from rules of inference. I will tell you what rules of inference means. These are important. Questions have been asked in GATE exam from them. I will tell you something about them. Don't worry. But you should remember this thing. Conclusion should be drawn from rules of inference. Like arbitrary, you should not be able to draw some conclusion. You should draw this conclusion from some rules. Some rules and regulations are there for arguments. So if you follow those rules and regulations, okay, then you will say argument is valid. Otherwise, you will say argument is not valid. Okay. So invalid means conclusion is obviously not drawn from rules of inference. You have drawn it like this, anything. Okay. So it's your imagination. By imagination, you have done all these things. This is wrong. So conclusion, if conclusion is not drawn from rules of inference, it is invalid. But if conclusion are drawn from rules of inference, then it is valid. Okay. Anyway, rules of inference I will tell you next from the next slide only. And another way of saying valid argument is this: P1 and P2 and P3 and up to Pn implies C. It should be a tautology. It is Boolean algebra kind of thing. Okay. So you will imagine that proposition number 1, 2, 3, 4, and up to n. All these are true. That's why I've written and between them. And this is your implication symbol which you have studied, like P implies Q. This is implication. C, the conclusion. Okay. So from these you should be able to draw the conclusion, or you can say from these premises implies this conclusion. So this should be a tautology. Only then you will say that argument is valid. And when argument is not valid, then from this and this, it is not a tautology. Okay. So if you want me to prove something like this, let me show you here. Let me jump to the previous slide on. You will get more clarity. See this. So if it rains, you take it as P. Children will not play, you will take it as Q. So if then this, so P implies Q. It rains is P. So what I am saying, P implies Q and P. Okay, and conclusion is what? Therefore Q. Children will not play. Children will not play is Q. So I have drawn the conclusion is Q. So if I say from Boolean algebra kind of thing, it should be a tautology. So let me show you the tautology kind of thing. I will say P implies Q and P implies Q. This should be a tautology. Okay, let me show you why this is a tautology. You can draw, you can easily say this thing. See, P implies Q is what? P bar plus Q. Okay, and P. So dot P implies Q whole bar plus Q. So now if you PB bar, it will be cancelled out PQ. So PQ whole bar plus Q. So P bar plus Q bar plus में Q. Q bar plus में Q, it will be 1. So immediately what you will get answer as 1. 1 plus something is 1 only. 1 in Boolean algebra, true in logic. True means tautology. So I have proved you that why it is so I have proved that this argument is valid. In front of you, I have proved that this argument is a valid argument. Why it is valid argument? I have changed it into logic and all, and I have proved you everything. Please try to follow it. If you have any doubt, you have to watch my previous lectures, because in that I have told you how to minimize expression from Boolean algebra and all this kind of thing. So now let me jump to the next slide now. Okay, yeah, and one more thing. Okay, so if I say if it rains, children will not play. Let me copy it because I want to save time. Okay, no problem. I will take it here only. Yes. So if I say if it rains, children will not play. I am writing in shortcut. Children not play. And next I say children not play. Conclusion is therefore it rains. Is it a valid argument? If you want to prove that it is valid or invalid from logic point of view, I have to prove like this. I will say it rains. Let me take a different color. Let us suppose this is P. Children will not play. It is Q. So if it rains, then children will not play. Like this I have written. So P implies Q. Children will not play is Q. So I want to say like this. P implies Q. Q. Therefore I want to say P. Is this a valid argument? So you will immediately say, sir, you can check it out. Okay, so I think I should give you as a homework. You will prove it. P implies Q and Q implies P. It will not come to a tautology. It will not be a tautology. So directly and indirectly I will say it is not a valid argument. It is not a valid argument. Okay, please, you can prove it yourself. I am not proving it. It's your homework. You can prove it yourself. P implies Q and Q implies P. This is not a valid argument. It is not a tautology. It is not a tautology. You can prove yourself at your home. It is not a tautology. Hence, this argument is not valid. Okay. So actually, we call such kind of things as fallacy. Fallacy. These all are known as fallacy. Fallacy means you think that they are true, but actually they are not true. Let me give you a real life example. You will get more clarity about all these kind of things. Let me give you a real life example. I am saying that if I have money, then I will buy a car. I will buy a car. Now I am saying I do not buy a car. I don't buy a car. So conclusion is therefore I do not have money. you will laugh on me. I do not have money. Clearly this is an invalid argument. But if you do not know logic, you will say, okay, this is a valid argument. This is the general perception of everybody. Na? General perception is what? If you have money, then you will buy a car. You do not have a car, so everybody will think that you do not have money. That is clearly a fallacy. Okay, this is the general thinking of every person, and this thinking is wrong. This is invalid argument. I have proved you. This is an invalid argument. If I have money, then I will buy a car. I do not buy a car, so therefore I do not have money. This is clearly bullshit. This is not good thing. Okay? So if I have money, then I will buy a car. I do not buy a car, that means I do not have money. Almost 99% people think like this. If I have money, I will buy a car. You do not have a car, that means you do not have money. This is not the good thing. Na? You should not think like this. Okay? So I hope I have made the point clear. So this is an invalid argument. Clearly this is an invalid argument. And why it is invalid? You can prove it. I have given you as a homework. You can prove it. It will not be a tautology. Okay, you will say like this. I have money. P. I will buy a car is Q. So it is I do not buy a car, not Q. So finally you want to say I do not have money. It is not the case. Okay. Yes, let me jump to the next slide now. Yes. So yes. So arguments I have done. I have given you introduction. So now let me say you all this. This is also a very important point which you should remember. If all premises are true, then we will say conclusion must be true. This is also a conditional thing. So directly I want to say if premises are not correct, then conclusion may or may not be correct. So see this example. 2 plus 2 is equal to 4 implies 3 plus 2 is equal to 10. Clearly this is an invalid thing. Na? This is invalid. Na? 2 plus 2 is equal to 4. This is true. And 3 plus 2 is equal to 100. This is clearly false. Okay. So I am saying if 2 plus 2 is equal to 4, then 3 plus 2 is equal to 100. This is meaningless thing. Okay. Now I am saying 2 plus 2 is equal to 4. So therefore I am drawing 3 plus 2 is equal to 100. Clearly this argument is not correct. You will think like this. But actually this argument is valid. Why this is valid? I have proved it. This is P, this is Q. This is P. So conclusion is Q. So P implies Q, P, therefore Q. I have proved it. See this. I have proved that this is a tautology. Okay. So clearly this argument is valid. Okay, but you are thinking that we are not able to make any sense out of it. So you are not able to make sense out of it because your proposition 1 itself is wrong. Since your proposition 1 itself is wrong, but your proposition 2 is correct, so finally your conclusion is not correct. So I have said this thing. See this. If premises are true, then conclusion must be true. So if premises are true, then conclusion must be true. This is argument is saying like this. So if premises are not true, then conclusion may or may not be true. I cannot say anything about it. Okay. So, but if you say argument is valid or not, this is 100% valid argument. 100% valid. Okay, and this is exactly what is used in court of law. If you have studied or you have heard something about law in court, what lawyers are doing, they are doing like this only. Okay, they will say this is your you can say person number 1 who is saying like you say na that he is saying like he person number 1 is saying that person X has done murder and so on. Okay, he came to the court and he has given the statement. Okay, person 2 has came and he is also saying that X has done the murder. Person 3 is coming and he's also saying X has done the murder. Okay, everyone is saying like this. Okay, so finally what judge will do? Judge will say, okay, all the premises are true, so therefore he will conclude X has done the murder. But if these premises are wrong, obviously conclusion is wrong. Okay. So judge, see, court of law is entirely based on arguments kind of thing. They will simply follow the logic. That's it. And they will assume that all the premises are correct. So they will say the conclusion is correct. Okay. But obviously this argument is valid. No problem in that. This argument is valid. But this conclusion may be wrong. Why this conclusion is wrong? Because some of the premises may be wrong. Okay. That is the basic problem in court of law. And nobody is able to say all these kinds of things that what is the solution and all. There is no solution to these kind of things. We have to believe them. If somebody is coming to court and he is saying that X has done the murder, then you have to believe him. There is no way out. Every person is saying like this. So finally, what judge has to say? Okay, therefore X has done the murder. He will draw the conclusion. But what if all of them are saying wrong? Okay, somebody has given them money, and finally they are saying wrong. So you will get conclusion is wrong. No problem, but we cannot do anything for this. Okay, please take snapshot. I am jumping to next slide now. Okay, so I am saying argument is valid, then conclusion should be correct. No, I have told you here. Argument was valid, but conclusion was wrong. Okay, so I am saying if premises are true, then conclusion must be true. That's it. So if premises are not correct, Okay, or you can say your propositions which you have taken, these are not correct. So obviously the conclusion may not be correct. So argument may be valid, but still conclusion is not correct. Yes, this. So I'm saying argument is valid and conclusion should be correct. So this statement is false. This statement is okay. Conclusion may or may not be correct. When argument is valid, conclusion may or may not be correct. I have told you. See this here itself. I have told you. Entire argument was valid, but conclusion is not valid. Okay. Yes. Please take snapshot. I will jump to the next slide now. Okay, so finally, now we are going to start rules of inference. These are the total 9 rules of inference which you should remember. Many times questions have been asked from gate from these rules. Okay, let me show you the rules. First rule is addition. Let me jump to the slide. Please take snapshot. Yes. The first rule is addition. What addition is saying? Addition rule is saying like this. If P is true, so you will conclude therefore P or Q is true. Another way of saying is Q is true, therefore you will say P or Q is true. Okay, so how you will prove that this is a valid argument? See, rules of inferences are nothing but small arguments only. These are small valid arguments. So by using these small valid arguments, you will be able to prove big arguments as valid or not. Okay, so these are just you can say blocks, constructing blocks. Okay, they will help you to construct a big building. So these are the small valid arguments only. So addition rule is saying like this: P therefore P or Q therefore P or Q. Okay, so how you will prove that this argument is valid? So you will simply say this is the premise and this is a conclusion. Huh? So P implies P or Q, that should be a tautology, and you can easily prove it. Why this is a tautology? You can say by Boolean algebra, I will say P bar plus P plus Q. Okay, I have changed it. Now P implies Q is what? P bar plus Q. So this will be as like this: P bar plus P plus Q. So P bar plus Q is nothing but 1. I think you already know. 1 plus something is 1 only. 1 means what? In logic, it is true. So true means tautology. I have proved it. Similarly, you can prove it like this also. So P therefore P or Q, Q therefore P or Q. So these are rules of addition. Now generalized rule is this: P therefore P or Q or R and so on. I think you know, na? In or, if any one of them is true, answer is true, na? So if P is true, then obviously P or Q or R and so on, it will be true. This is a generalized scenario. If you want me to show you an example, I have shown you example here. I go to office by bus. So conclusion can be I go to office by bus or car. You can draw conclusion like this. Okay, so you will say, sir, these are meaningless things. Why you are telling us all these kinds of thing and all? So see this. Actually, I go to office by bus. You are giving a statement like this. Okay, and in your legal documents in office wherever you are doing job, in legal documents, whenever I say legal means logic. Without logic you cannot prove something. So legal means logic. So in legal document it has been mentioned that I go to office by bus or car. If you go to office by bus or car, then you will get TA of 5,000 rupees monthly. So the legal document is saying I go to office. If you go to office by bus or car, then you will get 5,000 rupees. Okay. So you have given the statement I go to office by bus. So obviously, when you say I go to office by bus, this statement is true. So I go to office by bus or car is true. So definitely you will get 5,000 rupees monthly. This is the way legal team will work. Okay, they will not say common sense by common sense and all. They will not say like this. Okay, what clerk will do, what legal clerk will do, you will give him a statement. I go to office by bus. Now he will check his legal document and he will check the statement that go to office by bus or car, then you will get 5,000 rupees. Okay, he will say okay. You are saying bus and I am saying bus or car. So bus means bus or car, obviously true. So you will get 5,000 rupees. That is the way. Okay. So I hope I have made the point clear. Please take snapshot or something. I will jump to the next slide now. This is rule of addition. So now I am jumping to the next slide. Simplification rule. Simplification is saying P and Q. So obviously now you will say when P and Q both are true, so obviously P is true. Another way is P and Q, so obviously P and Q both are true, so therefore you will say Q is true. So it's very simple. So how you will prove it? It is true. So I will say P implies Q should be tautology, and it's homework for you. You will prove it yourself. Similarly, you will prove it yourself. This is really very simple. So generalized case will be P and Q and R dot 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 dot. So you will say P is true, Q is true, R true, all are true. So obviously P is true. You will say like this. So if you want me to show you some real life example, I will say like this. I am studying physics and chemistry in college. So therefore you will say I am studying physics in college. That's it. Okay, now same scenario I will say like this. So you have given statement to your see, if you study physics, you will get say 5,000 rupees stipend in your college. Okay, so you will get stipend of 5,000 rupees if you study physics in your college. So now you have given statement to the clerk, legal clerk, that I am studying physics and chemistry in my college. So he will draw the conclusion, okay, you are studying physics and chemistry, therefore you are studying physics, so you will get 5,000 rupees. That is the way they will deal all the things. There is no common sense kind of thing in legal things. Okay, they will simply obey the logic. That's it. Okay, so please take snapshot. I will jump to the next slide. Yes, I'm jumping to the next slide now. So next is conjunction rule. Conjunction rule is saying P, Q, therefore P and Q. This is also very simple scenario now. I will say P is true, Q is true. So obviously when both are true, you will say P and Q is true. That's it. This is known as law of conjunction. Okay. So so now I think I should not give example and all. I should not waste the time. Anyhow, these basic kind of things are not asked in game. So you should remember law of conjunction is P Q, therefore P implies Q. And if you want to generalize, I will say like this: P Q R S dot 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 dot. So you say P and Q and R and S dot 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 dot. Okay. Please take snapshot. I will jump to the next slide. Modus ponens. This is important. This is important. So the rule which we were talking again and again in that was modus ponens. So what is this saying? P implies Q, P therefore Q. So what I am saying is P implies Q is true, P is true, therefore Q should be true. And this is obviously valid argument. Why it is valid? First you can check it out like this. P implies Q and P implies Q. This should be a tautology. Homework, I have done it. Rather, I should not write homework. I have already done it. I have proved that it is true. Now, how you will think logically? I will say P implies Q is true. P implies Q is true, and I'm saying P is true. So therefore, Q must be true. See this. P Q P implies Q. False, 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 true, true, false, true, true. True, true, false, true. So I am saying P implies Q is true. So that means either these two cases or this case. Let me draw it like this. Either these or this. I cannot consider this because P implies Q is true. I have supposed. And I'm saying P is true. When P is true, okay, here in both the cases P is false. I'm saying P is true. So obviously when P is true, Q should be true. Therefore, I have drawn the conclusion that Q should be true. Okay. Yes. So and one more thing, one basic thing is coming to my mind. You can say like this also. P implies Q, therefore Q. So order does not matter here. You can do like this also, there like this also. Why order does not matter? Because and is commutative. You can put P here, P implies Q here. Obviously, one and the same thing only. Okay, so order does not matter. P implies Q, P therefore Q, or P implies Q therefore Q. One and the same thing only. Okay, so yeah. So let me show you one example. Okay, let me jump to the next slide. Please take snapshot. Yes. If it rains, I have told you in the previous few slides back also. If it rains, children will not play. It rains, therefore children will not play. This is completely valid argument. and proof is you will say like immediately by modus ponens. By modus ponens. Modus ponens. Why modus ponens is applied? If it rains, P. Killer will not play Q. It rains P. P implies Q. P therefore Q. Finally, we have got it. There are lots and lots of examples you can take. Like if I have had, if I am just making like this. If I had headache, then I take medicine. Then I take medicine. I had headache. Therefore, I take medicine. This is clearly true. Yeah. And let me copy it so that I can show you one fallacy. Yes. So, oh, I'm not able to copy it properly. Just give me a second. Now concentrate here. If I had headache, then I take medicine. Now I will say I take medicine. If I say like this, I take medicine. Medicine. Therefore, I had headache. This is clearly false. Like this, I am saying P implies Q. Q. Therefore, P. This is clearly wrong. How you will prove it? It is wrong. Okay. So by logic itself, you can prove. So I will say a P Q. P implies Q. False, 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 true, true, false, true, 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 false. So P implies Q is true. That means these three cases I am talking about. I will not take this case. Q is true I am taking. Q is true I am taking. That means what? See this. Q is true I am taking. So I am talking about either this case or this case. So now when Q is true, so obviously P can be false or true. I cannot say P is true everywhere. Obviously this is wrong. And that's why we call it as a fallacy. So if I had headache, then I take medicine. I take medicine, therefore I had headache. Sorry, therefore I had headache. I had headache. Okay, this is clearly wrong thing. Huh? If I had headache, I take medicine. This is P, and this is Q, and I take medicine. This is Q. So you are drawing conclusion that P. No, this is wrong. So you can take medicine for some other purpose also. It's if you have taken medicine, that means you have headache. That is not the good case. Okay, same scenario that I have buy a car. That means what? I have money. It is not the good case. Yes. So now please take snapshot. Yes, I will jump to the next slide now. Okay, this is fallacy. This is fallacy. I had headache, then I take medicine. I take medicine, therefore I had headache. No, this is not. This is wrong. Immediately you will say wrong. Now, how you will say wrong? You will immediately convert it into logic, and from logic you will prove it that it is wrong. Do not try to make any kind of sense out of it. If you try to make sense out of it, you will say, okay, this is valid. This is correct. Okay. So it may be the case that you have headache. It may be the case that you do not have headache. Still, you have taken medicine for some other purpose. What a big deal. Okay. So now I think everything is on one slide. Please take snapshot. I am jumping to next slide now. Yes. So next is modus tollens. What modus tollens is saying? It's say this. This is simple. It is saying P implies Q, and it is saying not Q. I will draw the conclusion. Therefore, not P. This is known as modus tollens. Modus tollens is known as rule of contrapositive. Rule of contrapositive. Okay. So why it is known as rule of contrapositive? So you can convert it in the form of modus tollens also, modus ponens also, like this. Contrapositive, see this, equivalent to this. Contrapositive and direct are equivalent, na? So you will say not Q implies not P. And you will say here not Q. So therefore, not P is the conclusion. So simple. If you are still not able to follow, you just take it as not Q, you take it as X, not P, you take it as Y. X implies Y, not Q was X. So therefore, conclusion will be what? Y. I have told you in the previous slide itself, modus ponens. Modus ponens and modus tollens are just like one and the same thing only. Okay. So modus tollens is saying P implies Q, not Q, therefore not P. Yes.
How are
And
these things?
okay, so I see I have proved na modus tollens and modus ponens are their proof is similar. Actually, they are not same. Their proof is similar. Modus modus ponens is P implies Q, P therefore Q. Okay, and modus tollens is P implies Q, not Q, therefore not P. And how I have proved modus tollens with the help of modus ponens only. Okay, from modus ponens I have proved you modus tollens. So I have told you that P implies Q is equivalent to saying as not Q implies not P, and not Q is as it is. So finally this and this. So finally we will get not P as the answer. Okay. So modus tollens I have proved from modus ponens only. Okay. So this is known as rule of contrapositive. Okay. And basically modus tollens is used in proof by contradiction. Whenever we do some proof by contradiction kind of thing, proof by contradiction. So proof by contradiction is nothing but modus tollens only. So we will first assume that the given statement is true. Then finally we come to contradiction, and then we will say the given statement was false. Okay, like we have studied in pumping lemma and all in TOC. We assume that the given language is regular, and then finally we arrive at a contradiction, and then we will say okay, our assumption was wrong. The given statement is the given language is not regular. So that kind of thing. So proof by contradiction, that is done by modus tollens only. Okay. Yes. So yes. So for example, see this example, you will get more clarity. What I was saying. See this example. If 5 is even, then 2 divides 5. Okay, so I have assumed that 5 is even. So now you will say okay. If you assume 5 is even, then you should say 2 divides 5. Now finally you will say but 2 does not divide 5. So conclusion is 5 is not even. So this is proof by contradiction example. I think you have got it, na? This is P, this is Q, so this is not Q, therefore not P. So we will assume that P is true. I will assume that 5 is even. So now you will say if 5 is even, obviously every even number is divided by 2, na? So 2 divides every even number. So you will say, you will assume that 5 is even, so you will say, okay, if you are assuming 5 is even, then by definition, you should say 2 should divide 5. So you will say 2 divides 5. See, 10 is even. Why 10 is even? Because 2 divides 10. You already know all these basic things. So 2 divide 5. So now you will say, but you know that 2 does not divide 5. So what you conclude, conclusion, what you will draw, that 5 is not even. That is known as proof by contradiction. So I hope I have made the point clear.
Yes.
So now, okay, please take snapshot. I will jump to the next slide. This is all about modus tollens. Okay. So yeah, and again we have a fallacy here. So I will say P implies Q, not P, therefore not Q. This is wrong. You can prove yourself also. P implies Q is true. I am assuming P implies Q is true. Now you are saying P is not true. So obviously Q is not true. No, Q can be the true or false. You can say like this, see this. P Q, P implies Q. So false, 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 true, true, false, true, true. So true, true, false, true. So these three cases we are considering. P implies Q is true now. So you are considering these three cases only. Now you are saying P is false. P is false. That means what you are considering only these two cases. Now when you are considering these two cases, Q can be either true or false. I do not know. It hardly matters to me. Q can be the true or false. But you are saying Q is false. No, you cannot say like this. So this is a fallacy. Okay, so same thing I can do here. if I have money, I will buy a car. So I am saying if I do not have money. So conclusion is I will not buy a car. No, I can take loan also. From loan, I can buy a car. Are you getting it? Now, if I will keep on writing everything, it will waste our time. Okay, so roughly I'm writing, if I have money, I will buy a car. Buy a car. I am saying I do not have money. I don't have money. So conclusion is therefore I don't buy a car. This is a general philosophy of everyone, na? So you will say if I have money, I will buy a car. I do not have money, you will say okay, I will not buy a car and so on. But another option can be you can take a loan and you can buy a car. Okay, so obviously this is a fallacy. This is not a valid argument. You may be thinking by common sense it is a valid argument, but it is not a valid argument at all. It is a fallacy. Fallacy means invalid arguments. Okay, I am jumping to next slide now. Next is disjunctive syllogism. Disjunctive syllogism is, say this. Disjunctive syllogism is P or Q, not Q, therefore P. Similarly, you can say like this: P or Q, not P, therefore Q. And if you want to generalize, you can say P or Q or R, and you are saying not P, not Q, therefore R, and so on. You can extend it. I think this is, I need not prove it. This is obvious also. P or Q. So I am assuming P or Q is true. Q not Q is true. That means that Q is false. So now I am saying P or Q is true and Q is false. So obviously P must be true. Huh? Therefore P is true. I think you have got it. Huh? If you have not got it, please you can check it out. Truth table. False, 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 true, true, false, true, true. So I'm saying false, true, true, true. P or Q. Na? So if any one of them is true, you will get it as true. So now these three cases I am talking about. I will not consider this case because I am assuming P or Q is true. Now I am saying Q is false. When Q is false, see this. When Q is false, only one case Q is false. So obviously P must be true in that scenario. So that's why I'm saying P must be true. It's common sense. P or Q is true, I'm saying P is false, so obviously Q must be true. That's it. This is known as disjunctive syllogism. Okay. So I'm not going into example and all, it will simply waste our time. Okay, it's really very easy. I think you have got it. Let me jump to the next slide. And these are, I think, making sense to everyone. These are very simple scenarios.
Yes, sir.
Next, yes. Next is hypothetical syllogism. Hypothetical syllogism is P implies Q, Q implies R, therefore P implies R. Okay, so I think I need not prove it. This is very, very simple scenario. P implies Q, Q implies R, therefore P implies R. Transitivity. Okay, transitive kind of thing you have studied. So it is just like that only. So why I am calling it as hypothetical? Because there are very hypothetical things. If P is true, then Q is true. I am saying if Q is true, then R is true. Everywhere I am saying if. That's why I am supposing now. I am supposing if P is true, then Q must be true. I am supposing if Q is true, then R must be true. So finally conclusion will be if P is true, then R should be true. This is known as hypothetical syllogism. Okay. And obviously I have told you it is known as transitive rule. Transitive rule of inference or implication. Transitive rule of implication. Okay. Yes. So I think I should not give example and all. It will waste our time. You have got it. Let me jump to the next slide. Next is constructive dilemma. What constructive dilemma is saying? See this. P implies Q. Let me use a different color. P implies Q. R implies S. P or R. Therefore, Q or S. Okay, that is constructive dilemma. So what it is saying? P implies Q. I am assuming P implies Q is true. I am assuming R implies S is also true. Now I am saying P or R. P or R means what? Either P is true or R is true. So the final conclusion will be what? If P is true, okay, you can bifurcate it now. P implies Q, P. Therefore, Q. You already know. Modus ponens. And R implies S. R implies S. S, add R. So your conclusion will be S. By mod exponents only. We have done like this. Now P implies Q, P, therefore Q. R implies S, R, therefore S. So I have combined these two and try to get it. So what I have got, P implies Q, R implies S, P or R. So that means any one of them can be true. So when any one of them is true, so finally either Q or R should be true. So that is the case. So either Q or S should be true. So Q or S should be true. Now why I am calling it a dilemma? I am in dilemma that either Q is true or S is true. I cannot say precisely which is true because I cannot say precisely whether P or R is true. Which is true, I do not know precisely. So that's why I do not know precisely which is true, Q or S. Let me show you something of this dilemma situation. You have got it many times in your colleges. See this. If I go to exam, I won't be able to perform well. I think so. Imagine that you have a fever or something. You are not well before the exam, and now thoughts are coming to your mind. Like if I go to exam, I will not be able to perform well. Second thought will be, but if I do not go to exam, I will obviously fail. So now you will say, I go to exam or I do not go to exam. Are you getting it? Are you getting it now? If I go to exam, I will not be able to perform well. First thought, if this will come to your mind. Second thought will be, if I do not go to exam, I will fail. So now you will be thinking that I go to exam or I do not go to exam. What should I do? So conclusion will be, I won't be able to perform well or I will fail. That is the conclusion. Okay. So there is a kind of dilemma here. Na? That's why I'm calling it as constructive dilemma. Okay, please take snapshot. I will jump to the next slide. Okay, constructive dilemma is over. So next is similar to constructive, we have destructive dilemma. Let me jump to the next slide. Next is destructive dilemma. What destructive dilemma is saying, this is the last rule. What it is saying, P implies Q, R implies S, not B or not S. Sorry, not Q, not Q or not S. Not Q or not S. Therefore, not P or not R. And it's really very simple. You have got it. Na? See this. P implies Q, not Q. Therefore, not P. I have told you. Modus tollens. Similarly, R implies S, not S. Therefore, not R. Modus tollens. Not R. Modus tollens. Okay. So from modus tollens, these two modus tollens, I have got it. And why I am calling it a dilemma? Because I do not know precisely which is false, Q or S. And so I do not know which is false, either P or R. Okay. So I think you have got it. So this is known as destructive dilemma. I'm not going into example and all, it will simply waste our time. That's it. So this is all about rules of inferences. So that's it. So we have now successfully completed predicate logic. So in the next lecture, we will be, we have constructed propositional logic. In the next lecture, we will start predicate logic. So we will tell you first what exactly is predicate and all. And then we will start predicate logic. I think you know now, there exists for all. Okay, we will study these things. Quantifiers, which we call them as quantifiers. So we will study them in the next class. Yes, if you have any doubt, you can ask me. Otherwise, I will wind up the class here itself. Okay then. Thank you so much. Bye bye. Good night.
Thank you, sir.